ready to go.
We turn it on. Turn things on will work much better. I can hear my voice in here, so I'm going to put the headphones like that. I'll start over. Thank you, Marcus, for the really warm welcome. I really appreciate it. I've really enjoyed Dr. Bastos's work over the years. I remember last time I was in Brazil, I saw one of your concerts and was quite amazed by it. It's stayed with me. I show it to my students sometimes. It's really kind of amazing work. And thank you, Johnny, for everything you do, and my longtime colleague Cicero Silva, who's in the back. Thank you for inviting me and arranging all of this. I'm deeply honored to be here. Thank you all very much for coming today. I get most of the joy in my life from working with undergraduate students in programs and talking about the histories of what it is that I teach, and then helping students begin to make those kinds of things. So I'm really very pleased to be with you all today. So about myself, Marcus gave a very good introduction to where I'm from. I'm from University of California, San Diego, where I teach in a major called Interdisciplinary Computing and the Arts, which it's just like in Brazil. Visual arts departments are very close to communications departments. The other departments that are around us and that we're at UCSD that we're in frequent conversation with are cognitive science, music, engineering, computer science. And the major ICAM was designed very intentionally by figures in the computing and the arts world like Lev Manovich and Adrian Jennick and Sheldon Brown, to allow artists to study computation in a way where they're equally fluent in computer science concepts. So our artists write software and do technology like electronics. You can see the various things that I teach there, but also that they have familiarity with cultural concepts and artistic concepts, and to talk about what the visual arts field's kind of focus is. Really, it's a relationship between the gallery, like a room, a white cube with white walls that you would hang art on, and our students make work for this particular kind of culturally specific venue for the entertainment of ideas and concepts and propositions about what art is. And there's also kind of a relationship with escaping the gallery, going far away from it, and doing things that are, related very carefully to doing things that are doing things that are within the tradition of the art world, but with, challenging that kind of hegemony of the white cube space, as we often call it. So we, sort of in the museum, out of the museum, and our students learn to use computation to make the kinds of propositions and projects that function within the art world, but that use contemporary technology. So they take a large amount of computer science. They study electricity and electronics and 3D and computer game programming. And the students, many of the students at the end of their course of work will be making sculptures out of electronics and motors and mechatronics. They will be, using 3D printing, additive and subtractive to make objects that they've designed in the computer. They will sometimes be using, many of our students make computer games as but an art game that's a proposition about the art world. So those are the kinds of things that I teach and that I do. Another thing that I do is I teach a large history class that introduces students to the different worlds of computer art. Because in a naive sense, when most people hear computer art for the first time, they think of very small range of potentialities in terms of media specific practice. They think of using a computer to draw, which is very important in our history, but it's limited to maybe thinking of using a computer to draw, to make pictures, to make, often to edit video and create, visual art with the computer. But in fact, the world that I come from is just like with communications, is as broad. It studies anything in the world and addresses media, particularly technological media, from all over the place. So my point is, when I teach our history course, I teach, histories of things like such as I've done in my career with Cicero Silva, locative media, like artists working with computer and GPS, or artists working with database, or artists working with virtual reality, or artists working with artificial intelligence is one of the things that I talk about. So in discussing this with my colleagues, that we, since we are in this high moment of interest in artificial intelligence, which I have things to say about, since we're in this moment of great interest in it, I thought I might come here, and what might be most useful for us to have a conversation together. Oh, and by the way, when we are done today, I look so much forward to your questions. I look forward to speaking with you after the event to share thoughts and ideas. That's the most exciting part of these kinds of events, is the opportunity to have conversation, or even a beer with an undergraduate is the best part of meeting people and meeting young scholars and young creatives, because I care about your ideas. We can't have only old ideas in the world. We need young ideas in the world. So I'm going to talk about computing in the arts, like 50-year experience with artificial intelligence. It's appeared once again as a major topic in media and culture. Artificial intelligence is having one of those high points right now. But the history of artificial intelligence itself involves many different moments of excitement about different technologies, and then many different periods of nobody caring about it at all. The famous, what we call the AI winter, took place between approximately 1980 and the late 1990s. There was 20 years of like everybody dismissing AI. And it came back in different decades. So there were periods of time when there's no concern for it. And I will say about my own discipline area, artists working with computation, we sometimes follow trends, as everybody else does. So at the times when AI was really, really big, there were a lot of artists in the past, in the late 1990s, and at periods in the 70s, who were working with these AI concepts. So I'm going to go through some of those histories with you today and share AI as a function of computer artists, and specifically the kinds of artists that, like I said, do things in art galleries, museums, who have curators, who have work curated into exhibitions, who make their academic propositions through installations, like I think most of you have seen, I've heard this, you've seen File 2023 festival at the, what's the name of the building? Help me. Fiesp. Go to Fiesp if you've gone already and seen that show. Fantastic, but it'd be great to go look at that art exhibition after this talk, because I hope I can help you apply some of the relationships between techniques in artificial intelligence and the kinds of aesthetics that artists develop for installation artwork in a gallery, for those kinds of things. So I hope you enjoy. It's a little bit of an unusual talk about a deep and narrow subject in a particular field that overlaps with yours. And I hope there's something that we can all talk about and take away from this. So just a little bit of history. Joseph Weizenbaum, 1966. Many of you will know this software called ELIZA. ELIZA was the first chatbot. And it was a very, very, actually, computationally very simple piece of software. And I'll show you an example of my conversation with it in a second. But a very, very simple piece of software. And Weizenbaum, wrote this, published about it. He wrote a very good computer science paper about it in the 1960s that I have my students read. And later in his life, so this becomes a phenomenon. It's still famous today. It's still fun to play with today. But he notices that humans, even though this is a very, he would say this, he would agree, it's a stupid piece of software. It's dumb, right? It's not good artificial intelligence. It's just a simple algorithmic contrivance. But people would develop emotional relationships with Eliza. So for much of his career, he talked about this danger of artificial experience, of humans projecting onto the chatbot, something like intelligence or something like an emotional relationship of understanding. So here's a chat that I had with Eliza when I was preparing my class for my students one night, and I was sick. I had like one of the worst flus I ever had. I'm coughing, in pain. It feels ridiculous. So I just tell Eliza my problems like everybody does. I say to Eliza, I have a bad flu. And Eliza says, that's quite interesting. She's interested in me, right? Then I say, thanks for your concern with my phlegm. And she says, why are you concerned about my concern for your phlegm? And then I tell her honestly, honesty is important. I'm not really concerned. I know Eliza's a chatbot. Then she says, do you come to me because you are not really? To point out, this is a very bad sentence just in basic English grammar, right? It doesn't even make proper English at this point. And I say, I am not really. Yes, which is an equally bad sentence in English. And she says to me, do you believe it is normal to be not really? Yes. And at this point, I'm captured by the my knowledge of what Eliza really is and how Eliza really works, and I kind of put her down, insult her a little bit. I say, it's normal for you, right, to not really be. And she seems to recognize, oh, right. Like, oh, right, I'm a chatbot. I'm not real. And that's the kind of what this would mean in English. That'd be a connotation of this conversation is like, I'm not real, I get it. Which is actually true because she's not real and it's a very simple, stupid algorithm. And everything that we're looking in this that might be philosophically deep is not. It's completely fake. It's really bad. But it was a kind of nice moment with a chatbot where you can sort of see how people would slip into an emotional, oh, the bot understands me, okay? So to show some art early, this is a 1999 piece of art by an artist by the name of Ken Feingold, and it's simply called Head. That's the name of this piece. And I'll give like 30 seconds or so. I know this will be terrible for streaming, but I'll give 30 seconds or so just to read, so you can read the character of the conversation with this chatbot that Ken Feingold, computer programmer, really good artist, designed. And he has obviously added his own sort of character to his chatbot. So I'll give you a second with that. And of course, I failed to mention out loud that there's an animatronic head. So you walk up to this head and you talk to it, and it does, voice to text recognition, feeds it into the chatbot, then it produces this text, but it actually speaks this back at you, which is very, very good for an animatronic head. The technology is like actually quite impressive for 1999. But I'll give you a second with the sort of the character of the conversation. So I think that's enough time to have a quick read to understand sort of the character of the conversation that's taking place here. And obviously it's about, you know, a character that the artist is trying to create in the chatbot that's obviously quite different from Eliza. A little grumpy, you know, a little bit disconcerted with his own situation. It's a very, very nice piece of artificial intelligence art. So early computers, some of the first machines that artists in the 1960s were able to touch and start to learn to write software for were very limited machines. And in fact, the only media that early computation could deal with, the only medium it could touch was language, right? In the 1960s and into the 1970s, the most common way that computers were used was, of course, just calculation, maths, adding up bills and things like that. But people were working with kind of conversational interfaces with computers as well. This is where like what you would call the Linux command line today came from, where you give the computer a command by typing it and hitting enter. That text goes into the computer processes the text, it gives you an answer. It can be used to control a computer's operation, or it could be used for a chatbot. That's the kind of model that we're talking about here. So one of the histories that artists have been, so what maybe the first history of kind of artistic engagement with computation through artificial intelligence, introducing artificial intelligence, is through the chat interface. And there are many other things we could talk about right now. We could talk about Alan Turing. We should, but we won't. We don't have time to talk about, sort of histories of how, intricate histories of how computer user interface and, user experience design develop. But we'll pass over quite a bit of that to try to get to something that is one of the points that I'm trying to make that comes from my experience. By the way, I'm an old professor. So, now is the time in my career where I, take account of my experience being a computer artist for 40 years now and look back at some of the moments and some of the things that we did as young people working with computer and computing in the arts. So I went to graduate school at a place called Cadre at San Jose State University in California, which was the first computing and, well, there's an argument between two different schools, the other one being in New York, the School of Visual Arts in New York, about who had the first master's degree MFA program in computer art. Where was the first places that you could study an art degree with computers as the primary medium. And Cadre is one of the two places. It's founded by Joel Slayton. It's one of the two places where computer art was the degree program in an art department. And these are one of the things that we would do when we were just experimenting together as graduate students. Oh, by the way, this was a very different time in history. No laptops, forget about that. Like if you wanted to use a computer, you had to get up and go to a computer lab. The only computers were in the computer lab. So this is an amazing thing, reflecting on this time in history. I knew my other graduate student colleagues. We sat next to each other, right? And made work together and looked at each other's screens while we were doing artwork. So these were one of the kinds of things that we did was we discovered translation software. So again, back to the theme of computers operating on language. Well, by 1999, computers are operating on language, but they're operating on language, in ways that aren't as good as today. And this is going to be a little bit my point. So we'd play Telefono Simfio with translation. So we would take a sentence in English and we'd translate it in, of course, to Portuguese. And then we translate it from Portuguese to Chinese. And we translate it from Chinese to Punjabi. Any languages, we would go sometimes through 20 languages. And every time the message would get translated improperly, a little bit differently. And this was delightful, right? This is one of the things of computer artists discovering the mistakes in the medium and bringing them to the foreground. And the kind of thing that artists still do with computers today is have the experience, like the cultural experience of dealing with these interfaces and reflecting on their abilities in ways. So there's many artworks that are made actually to make fun of graphical user interface and its flaws and its frustrations, right? So we would just sit around and we write software to scrape, the output of Babelfish, and then we'd have the software do all of these translations automatically, so we could just type something in and it would print back to us something that was really strange. This is a quick picture of what Alta Vista, that, by the way, Alta Vista was the Google of 1999. They came up with they added this language translation system in 1999, and it was bad, actually. It was really bad. This is what made the translations fun. So it'd be something like this. But I'm doing this in Google Translate today because I'm trying to this is a slide about, it's not a true slide. The slide is a lie, but it's about what it was like. I'm trying to convey something. So we would type into Babelfish, not Google. We live in a world where there is more and more information and less meaning. And we would go through all of these languages, right? By 2024, it comes out as almost perfect. In fact, there's just one difference. It corrected my capitalization. So I translate, and it actually made it better today than my original input. But in 1999, and again, this is completely fake. This is not a real example, but it might say something like, who knows, we could be in a turtle's dream in outer space, would be the wrong translation. And that was delightful, right? It was better when it didn't work, at least from the perspective of an artist, right? Everything that Google has accomplished with translation is amazing, and we all admire and use it, but it's also like completely boring, right? We can't have fun with it. But I was really delighted to see an artificial intelligence that I'll show you next. It's a film. It's a short film. It's called Sunspring from 2016 that actually utilizes, in 2016, our translation software was still not very good. So anyway, I want to show you this movie to look at, this isn't translation software anymore. It's actually artificial intelligence. And what they did was they trained an AI with science fiction scripts. So, and then they had the AI write a short fiction, science fiction story. So let's take a look at this. This is kind of fun. We won't watch it all, but we'll watch some of this. Get out of my way. Wrong window. Okay, good. I want to apologize to the translators here too, because if you could translate the words that are on the screen, okay, because Google, YouTube isn't going to translate the text. Thank you. I don't know anything about any of this. This is that Eliza moment of, yeah, really? That's really the point. I'll stop there. I don't know. I don't know what you're talking about, right? Is the AI speaking in terms of writing this script? I love, that's a really good movie. That's a really good project. Let me go back to my slides. So, let's see. Somehow I've got. So, this may seem like a little bit of a turn in the paper, but I want to talk about a turn in my talk, but I want to talk about this very, very important paper, which should, all of my students are going to be reading now for the next, as long as I continue to teach. It's called On the Dangers of Stochastic Parrots. Can Language Models Be Too Big? And this is by Emily Bender, Timnit Gebru, and other collaborators. And the importance of this, what they mean by stochastic parrots is they're making a characterization of the kinds of AIs that are popular today, or that are, changing many things, in fact, today. They're very, very important to understand. One of the points they make in the paper is that it's very, very important to understand kind of their histories. Maybe they don't say genealogy, but they kind of give a little bit of a genealogy of AIs in there to talk about how they work, sort of their history. And a little bit, they're trying to get under the covers of what the machines are really doing to produce natural language. The language models for natural language processing. And then the reasons this became such a famous paper, talked about in the media all the time, argued about between Emily Bender and Timnit Gebru and others, and Silicon Valley. Silicon Valley hates this paper, by the way. Sam Altman, the founder of OpenAI, has spoken openly against and somewhat, almost gaslighting against this paper recently in the news. He says, do people still really believe this? And yeah, I do. So other things that the real thing that they talk about there that really got the media attention was the issue of algorithmic justice and algorithmic bias in particular. So the issue of, if we're training our AIs with data from the internet, how is it that all of our cultural aspects, for example, racism, gets from that training data set and into the behavior of something like ChatGPT? And these are scholars that have very, very kind of strong critiques of that, and talk about how it is that an AI can be racist. And they want to talk about, making safer AIs, et cetera. So that's what the paper really, really became well known. But there's a really nice moment in the paper where they go toward linguistics, right? And they describe how when we're in a conversation, that if I'm speaking to you, I have a model of who you are, what your expectations are, what the conversation is about, what the context is. I'm a professor from somewhere sitting in front, you're sitting in the chairs, this creates a context, right? And you have a model of me. You're thinking about who I am and why it is I might be saying the things I'm saying. And these are very, very important concepts in linguistics related to communication, right? And basically the case they're making with stochastic parrots is that is not in AI, right? It's not there. It has a model of all of the output of language that has been collected from the internet and used to train the models, but it doesn't model you, right? It doesn't model the context of who you are, where you came from, what, environment that you're presently in. So they make a very strong point about that too. Even though it's mostly talked about in terms of AI safety and algorithmic bias in the media, it's a very good paper for other reasons because it helps you understand, at least approaches, what AIs are, like really what they are. And this is something that's important to artists, I will say. Artists who work with technology care about what the machine does. We like to try to get inside and figure out what the medium is. We're a discipline area that deals with media ranging from painting to performance art to sculpture. We care about, as artists, the materials we use to make a sculpture. That's very important. So for computer artists, like what the algorithms are, how they're constructed, what the computer science models are, to try to understand those is something that in computing in the arts is a very, very important thing. We love computer programming. We love reading computer science papers. Computer artists are really getting into the guts of the machine to understand what our medium is that we're working with, because we think very much in terms of medium specificity. So this is a very important paper. Everybody should go read it. But this is a very, very brief description of very generically how contemporary artificial intelligence is organized internally, okay? They are, the things that we're talking about here are language models and large language models, specifically the Stochastic Parrots paper thinks about what happens as they become larger. So we make a distinction between language model, large language model. But on a more basic level, the inspiration for neural network programming is based on biology. It's based on the function of the human brain. It's based on how cells are connected to other cells. Literally in neural network models, we talk about synapses and one cell firing to trigger another cell, and then it triggers another cell, and somehow all of what it is, our behavior emerges from this complex networks of neurons talking to each other. Like I said, cognitive science is a department our visual arts department at UCSD is very close to, because we think about their research very carefully. And then the second important thing to understand about these kinds of models is that we don't, we train them with big data. We take all of this behavior, in the case of language models, linguistic behavior, and we feed them into these inputs. And then these hidden cells, we really think of them as neurons, in the middle learn, they adjust I'll show in the next slide what they adjust, but they adjust some things, and we feed them and they adjust some things. And of course we do things like test them against other data to see how well they perform. And then the output is. So what we have here is we have the input layer. So if we talk about, you've all used ChatGPT. If we talk about ChatGPT, the input layer is you typing something in. The output layer is it spitting something out. But in the middle are all these numbers that have been trained on the language that are, in a sense, this really is what the word stochastic means in this case, is like, it looks at the sentence and its context, and it looks at its sentence structure, and then it, predicts the next most likely word. For every set of words, it looks for the word that's kind of most likely to be the next word based on the training of this model in the middle. And that's why they say parrot, right? Which, if there's I have any criticism of this essay, it's like, I think parrots are actually smarter than that. I think it's an insult to call a parrot like unintelligent, or that it just repeats what you say. I think parrots actually have a model of humans. I think they have a model of the people they live with, and they manipulate the people they live with just, in an exchange. Manipulate's a strong word. They interact with the people they live with. So I think parrots are actually, smarter than AIs, or parrots have intentionality, AIs don't. Okay, so that's a little bit about what they are. And this is just an interesting aside. We're basing so much of our economy now and turning over functions to artificial intelligence, and you all do it. I do it too. We all use ChatGPT or something else to learn something we don't know, right? fortunately, at this point in history, we've all learned not to trust it, right? We know ChatGPT hallucinates like crazy and will tell you crazy lies. I think that's interesting. They're trying to make the crazy hallucinations leave these large language models. I think that's the only thing that's really interesting about them is the hallucinations. But anyway, this is, it's a field of applied mathematics. We know how to make them. We don't know why they do what they do. We don't know how they do it. You take similar data, like just rearrange the input data that you use to train it. You end up with, I've put inside the hidden layers, they have weights and activation functions. So what the algorithm that trains the AI is really doing is just changing those numbers to different numbers. So if we take the same data and train the network again, but put the data into the network in a slightly different order, we can get a large language model or any kind of language model that works just about as well as other language model, but it has different numbers in the weights. So every training it with the same data doesn't always produce the same numbers. So we don't have strong theory yet about why the numerical values that end up in a large language model work the way we don't know how they work. We know how to make them. That's just an interesting aspect of these kinds of things. By the way, we don't know how these things work, right? So there is an aspect to these, neural network models that they're a little bit like us, right? We hallucinate too. We make stupid mistakes, right? We say crazy stuff. I say a lot of crazy stuff. So, in a way, we've invented these things that are kind of like us, and then we're trying to, take away everything that makes humans interesting from them by making them perfect, which is also a fool's errand. But anyway, that's a different conversation. So, yeah, this is what they say about it in the essay, in the paper. A language model is a system for haphazardly, this is what they mean by haphazardly, stitching together sequences of linguistic forms. It is observed in vast training data according to probabilistic information about how they combine, but without any reference to meaning. That's the important part. Eliza told me this. You saw my chat, right? No reference to actual meaning, really. It's what Sunspring, the movie, says, I don't know what you're talking about. Literally, it's like a message from the AI that they don't know what they don't have intentionality. And we can talk about John Searle. I'm sorry I didn't translate this slide for you, but John Searle is an important American philosopher and, let's be honest, a kind of bad guy and sort of abuser of his graduate students that needs to be discussed because he did bad things at UC Berkeley. But he did come up in 1980 with this famous argument called the Chinese room argument. But it's basically the same idea, is that the AIs they don't have any intentionality. They don't know what, they don't have knowledge or experience or intentionality in any of the ways that we do. I won't go through the exercise because it's kind of boring and super famous, and you can look up the Chinese room argument. But it was a very important argument in 1980 because it played a role in introducing one of the AI winters, where people sort of lost faith in artificial intelligence and research slowed down, and there were no more companies being made, and it kind of fell. And he has some very, very good points about that, but then we don't have time today. So, and I also mentioned, the dangers of these stochastic parrots. And that's really why you should read the Stochastic Parrots essay, is to think about, start to think about like where we place these in business and culture and what we depend on these kinds of AIs for, that this is a very, very important topic. And of course, Silicon Valley doesn't want to think about this as much. Well, they do, but they're very, very susceptible to any kind of, they don't like any kind of criticism, and they're very powerful and very rich, and they do everything they can to stop any criticism of the kinds of AIs that are out there. In fact, oh wait, all right, I need to go back. I'll get to that later. I'll tell a little bit of the story of Tim Gabru a little bit later. But instead of going through these I just want to show an example of what they mean by the dangers of AI. So this was a Microsoft project, also from 2016, when natural language processing, large language models also didn't work very well, which is delightful in Sunspring. But Microsoft decided to use this kind of technology and put a chatbot called Tay onto Twitter. And Tay only lived for 16 hours because Tay learned from Twitter. And Tay started out as a very nice 19-year-old girl and turned into a racist asshole in 5 hours. Tay learned from Twitter, like very, very deep, awful racism. So a little bit of a trigger warning. I'm going to show some stuff from Tay that's bad and also funny, but it's bad, right? Tay says we're going to build a wall and Mexico is going to pay for it. It was 2016. This was Donald Trump running for president in the United States. This was all over Twitter. You know, this is one of his very, very many, but more famous, really bad predictions because, you know, Mexico didn't pay for it. Mexico said no. I don't know how anybody couldn't see that coming. But anyway, yeah, you know, Tay, are you a racist? And Tay says, because you are Mexican. You know, just bad things. Tay, do you support genocide? Derp, I do indeed. Right? And Microsoft got very embarrassed and killed Tay. Actually, they kept working with the language models, of course, but there's some other stories. So that's a problem they're talking about. And I've talked about the problem that Joseph Weizenbaum brought up with artificial intelligence way back in 1966, well, after he created ELIZA in 1966, which is the problem of humans identifying with the AIs. This is another thing that we sort of have to deal with, right? You know, Japanese robot owners reminded not to fuck their robots. Or the kinds of relationships that you can develop, like social relationships with a chatbot. You know, these are things that are happening in the world. So it's sort of these two entities and these problems that go in both directions, which is really interesting to artists, right? And really interesting to the field of communications, very, very much so. So I'll tell some of the other stories. I'm mostly just telling stories today. I'll get to more art, I promise. But Timnit Gebru, a AI researcher working on AI safety and algorithmic bias. Her research led her very famously to be fired by Google. Although Google says she resigned, they argue about whether she was fired or she resigned. Google won't talk about it anymore. I believe Timnit. But anyway, she's somebody I think you should know. I think you should follow this person. Follow her on Mastodon. Don't be on Twitter or X. Be on Mastodon. And follow her there because, you know, she's like one of the world's experts who's like most engaged with AI safety and algorithmic bias, and is a super interesting person. And I think why wouldn't you? This is one of the first people in the world, if you care about artificial intelligence, follow this person. But anyway, she wrote also, she came up with other scholars, a neologism called techrealism. And techrealism, I'll let you look it up. I'll just give they describe it as, it's an acronym for transhumanism, extropianism, singularitarianism, cosmism, rationalism, effective altruism, and long-termism. And she describes this as sort of the philosophy of Silicon Valley, the philosophy of Sand Hill Road, right? Talks about how we're going to use, how figures like Sam Altman and OpenAI and Elon Musk are using, the threat that AI presents to us as a reason to regulate the industry. So basically they can control the industry. Nobody else can do AI, those kinds of things. She's talking about these philosophies as driving the business of Silicon Valley. And the struggle is real. Like just the other day, the reason I bring this up is because this August, somebody tried to remove this article from Wikipedia, right? Not Silicon Valley, but somebody who's like, one of their ideological sort of, you know, fellow travelers, I guess. And this article and this term is, you know, there's really a strong fight to like get it out of our language, to remove it. And, you know, so if you follow her, you'll be able to, you know, follow these historical battles for even how we're going to talk about how Silicon Valley and industry are implementing these things as products in our day-to-day life. This is where you can learn more about it. Okay, I promised I'd get back to art. So let's talk about, you know, I'm going to talk about artists, and I'm going to talk about some, this is the rest of the talk. I'm going to talk about artists. I'm going to talk about different historic AI techniques, and I want to look at them and think about them in terms of how the underlying medium, the technology itself, how it works, becomes visible in the artwork, how it becomes an artistic aesthetic in you know, literally like the language models or the neural networks inform or leak out into the aesthetic of the work later because of its media specific properties. So Memo Acton, I got the slide out of place, obviously. I have a better picture, but Memo Acton is what I should say here. Memo Acton is a colleague of mine. He's somebody, when you're done studying here, you can come to UCSD in San Diego and study with Professor Acton as an artist and make AIs and make visualization. You know, you're a related field. You can definitely think about programs like our MFA program at UC San Diego if you're making things that go in galleries, of course. But let's look at what Memo's one of the maybe really famous artists. Had a very well-received, successful project at the Venice Biennale recently. He's our colleague. We're very proud of him. So let's take a look at some of the. So in this case, we're still talking about neural networks, but we're talking about neural networks which deal with images. And it's the technology, there are more names to the technologies, generative adversarial networks, you know, which is basically where you have neural networks fight other neural networks for the best answer. You know, it's very, artificial intelligence research is quite marvelous and diverse and creative right now in a way that's great. But what his question was in this piece, I'll show you a little bit of his video. The question in this piece is, if a network is trained with certain kind of images, by the way, this is Google DeepMind. This is also like early, you know, like 2015, 2016 AI. But for the artist, the question is, what if it's trained on a certain kinds of data, what happens when it doesn't get that data? What happens when it gets something else? In other words, what do the hallucinations look like when we put it in a position to hallucinate? So we'll take a look at this. Oh my goodness, that's awkward. I wish I'd pre-cached this. It's probably just because Vimeo is a bandwidth hog. Oh, here we go. I'm sorry, I don't have the volume on. So it's seeing other creatures with eyes, but it's not seeing humans yet. Of course, today, by 2024, they see humans very well. Whoops. I hope I didn't shut. Okay, let's look at another project. This is called, oh no, oh good. So in this piece, these are AIs that are trained to see natural landscapes. And let's see what he's doing with them here.
Sunday, I waited and waited with clouds in my arms. All the dream I created, I waited till dreams like my heart are over.
I apologize. I do this to my students too. I've never finished showing a video in my life. So I'm going to move on, but Memo Acton, you know, look up his work. He's a very, very interesting artist working today with AI. And I got my slides a little bit out of order. I'll come back to some other neural network AI in a minute. AI and art, I got those out of order. AI and artificial life. So this was a field, this was a major development in artificial intelligence. And it's based on, you know, Darwinian survival of the fittest sort of models, but applied to computer programming. So what you would do is you'd create a bunch of computer agents and you'd release them into an environment and you'd let them compete with each other. And this has, for certain problems in computer science, this has a you know, kind of a very, very strong history of success. The two important concepts that come out of this differently biologically inspired metaphors for artificial intelligence are cellular automata and genetic algorithms. So cellular automata are these things. They're dynamical systems which are discrete in space and time, operate on a uniform regular lattice. I'm sorry, I didn't translate this slide for you. They're discrete, they're rule-based. John von Neumann, who is the progenitor of the kinds of computers we all use today, called von Neumann machines, was in the 1960s actually one of the first people to start to work with these ideas, to create simulations where, you know, often in the context of game theory at the Rand Corporation, you know, to play out scenarios for warfare and things like that, began to create computer programs that had, you know, competitive agents that fought with each other, and the idea is to see kind of who wins. And then there are artificial life, genetic algorithms. And this is where you represent a computer science problem and develop an answer to the computer science problem by finding the answer. So what you do is you create a population of potential solutions to a problem, and then you kind of mate them together. And then you pick the fittest ones. And for example, you kill half of them and you keep the fittest population. And then you breed them together again and create another generation and pick the fittest generation, pick the fittest answers. And you move toward an answer, a function that solves the problem that you're looking to solve. And so, you know, these are very 1990s ideas about artificial intelligence. So here are some artists who sort of dealt with those ideas. Carl Sims makes this piece called Galapagos. And if you look in the left picture, what you see is a bunch of computer screens with a 3D creature on them. And the idea is the audience in the gallery walks up to the piece and stands on that pad to look at that piece. And the ones that stand longer are getting more promotion for their survival because they're liked by people more. And then he kills the ones that fewer people paid attention to. He keeps the ones that people paid more attention to. He breeds a new generation. And this art installation shows that genetic algorithm playing out over time. And over time, you get to the people's favorite creatures on the screen. This is 1997. And by the way, these are really beautiful graphics for 1997. This is really strong, graphically strong work for 1997 too. Quite an amazing piece, very early. Some, you know, these are some artists from Europe. I'm going to get this wrong. I believe they're Dutch. I apologize, Maria and Erwin, if I'm wrong. Maria Verstrappen and Erwin Driessens do these projects with similar ideas, where they run kind of more cellular autonoma algorithms. And in this case, they run the algorithm, but they create a 3D print. So it's how does the algorithm produce for us the shape that's going to be the sculpture. Artists are frequently interested in getting outside of the computer and just into something as simple as a sculpture. I don't have these with you. I won't talk about this piece. Here's a lovely piece by Krista Sommerer and Laurent Montagneau. I'm sorry, Laurent. I've never been able to pronounce your name correctly, and I'm bad for it. But they make this interactive garden, right? Where it's a physical installation. These plants are hanging, but you can see behind it that it's computer screens. So the plants that you touch are the ones that become more influential in the artificial environment of plant growing algorithms behind it. Like a very, very beautiful piece. 1992, right? So artists have had a relationship, have been making, these very, very interesting computing in the arts projects from artificial intelligence ideas for a very long time. This is another piece they did, a very famous piece called Evolve, and it's very beautiful. It's a flat computer screen, and it's designed to be like a pool, and it actually has a layer of water over the top of it, and you reach in, but it's a computer screen, but you touch the water, and it follows your hand, and you can interact with the creatures in the water. There's also a screen where you can draw your own creature and release it in there, and then all the creatures enter into this kind of evolutionary, dismal Darwinian competition of the finest to survive in this artificial pool in front of you. So it's a very beautiful interactive piece from 1994. And those of you that have been to the File exhibition are maybe starting to recognize some things, that some of these ideas that you see in the current File exhibition, like an artificial life project, is a very good one there. I really suggest it's a very nice show. It's a very, very good show, very, very interesting to think about. But this work from 1994 would stand up very strong in this exhibition today, actually, I think. This is such an important piece. There's a style of artificial intelligence called expert systems. And expert systems aren't really artificial intelligence, I'll tell you the truth. They're really tree structures where they interview experts, and the experts give the knowledge about how to do something, and then it's implemented in regular three control structures, Bauman Jacopini's three control structures, selection statements, sequences, and looping iteration. They were implemented with older computing technology that is still very important to learn computer programming, but they capture the knowledge of the expert, right? So this is Harold Cohen, who used AI to create a computer program to encapsulate all of his ideas about composition and design and color. And he's a very important artist. He has shows, and he's deceased. He has exhibitions all around the world at important museums right now. He's a very, very super famous artist. If you go to museums, you will, in the next 5 years, you will certainly see his work. I just predict that. And by the way, he's the founder of Computing in the Arts at University of California, San Diego, where I am. He hired the guy who hired me. Yeah, it's an expert system. It's really kind of regular computer programming that captures all of his ideas about painting and drawing and making pictures. This is him in 1994 with his artificial intelligence system doing still plotter-based large format printers at the time, as you can see, implementing his paintings for him. There's computer vision, which is a field of artificial intelligence. And computer vision is a computer's ability to recognize objects or actions and things like images or video, okay? And David Rokeby, 1991, was already kind of working with these ideas as an artist. At the time, these ideas are being developed about computer vision. But I have to talk through this piece. It maybe is a little hard to understand, but I will try. There's a pile of objects on the floor, and there is a podium. And there is a camera connected to the computer pointing at the podium. And you are free as the audience to pick up an object and place it on the podium. And the computer recognizes the name of the object that you put on the podium. So, you know, something like bowling pin, ball, it recognizes those objects. And then he would use those as input to generate a story, an algorithmically generated narrative that would appear on the screen. So you as the audience are changing the story that appears on the screen as you put different objects on the podium for the artificial intelligence to consider as input to generate the poem. It's a really lovely piece, very interesting artist, very early working with some of the what later become key fundamental technologies of object recognition that we all suffer from every day today. This is Maria Verstappen and Erwin Driesens again, Tickle Salon. What this piece does is you go into the museum or gallery and you lay down, right, on a table, and the computer vision system looks at you and it moves this little tickler around to like tickle you very gently on the actual shape of your body because it recognizes the shape of your body. Again, a really kind of delightful project, you know, still fairly early, 2002, using computer vision techniques from AI to create a performative kind of installation art piece. So I think there's a whole genre of computer vision pieces. There's a wonderful, I think it's called Echo, but I forget. Maybe somebody who's been to the show can help me, where you walk in front of it and it sees you and it creates two delightful skeletal characters that follow you around, a male and a female. What's it called? Ego. And who was the artist? Do you remember? Yeah, really nice piece. But that's a piece in artificial intelligence, if you go to the file show, that uses computer vision. It's the robot seeing you and doing something graphically with you in a kind of magic mirror scenario. So computer vision is a genre, I argue. It's a genre of artificial intelligence. Here's some more neural network AIs. This is a very nice piece. Mark Bolin and TJ Rinker from 2003, 2005, called Universal Whistling Machine. And what they did, I love this piece because it's also an example of artists who trained their own neural networks. And what they did was they took recordings of a canary and long recordings of a canary and trained an artificial intelligence to make sounds like a canary, right? And then they put the two together. So what you have is a real canary in a cage, and you have the artificial canary as a speaker. And the artificial intelligence speaks gibberish, I'm sure, canary, to the canary. And the canary answers it back. But over time, that's the really beautiful part of this piece. Over time, both the canary and the AI's language change because they're both changing each other. So they start to evolve a new canary language, right? Which is, you know, a very, you know, early in the history of neural network processing artificial intelligence, that they're grasping what I started with today, this troubled relationship between the biological impressing its emotions upon the machine and the machine not recognizing the biological and what emerges from that. And as artists, they're not answering the question. They're just experimenting with it and exposing us to this changing canary language over time. And that's a remarkable piece of art. Mingyong Chen and collaborators are training. They did this project Landscape and Beyond in 2001, and Mingyong, by the way, I'll brag a little bit. She's one of our graduate students, and she does, she has, quite a. This work is very, very successful and well received. And what her concern and the concern of her collaborators is kind of their term for this is cultural memory. It's the memory of Chinese painting and Chinese landscape. And they train AIs with Chinese landscape. So they train them on Chinese landscape, then make movies, which I do have a link for that here. So let's take a look and see. Oh, not there anymore. Okay. I'm sorry, I don't have the file. This is one of those things that you'll have to believe me on. But they're beautiful movies of moving through Chinese landscape paintings. And they made this interesting discovery in the process of this, is that in Chinese landscape painting, there are frequently Chinese ideographic characters. So they're training an AI that's designed to learn images, but the images they're training with it happen to have Chinese text in them. So in 2021, I don't have a picture of it. I apologize for that. I switched computers, long story. But the output, the movies they would make would also show Chinese ideographic characters, except that they describe as gibberish Chinese. It had the linear and rectilinear flourish of Chinese ideographic characters, but it was not Chinese. It was something else, because the AI didn't learn language. It wasn't designed to learn language. It was designed to learn image, and so it completely hallucinates Chinese characters in the Chinese paintings that don't exist, which is for me personally, it was like one of the earliest, best examples of an AI hallucinating, which is a remarkable thing. So this is I think an artist and researcher to keep in your minds. She's super interesting. Also, I'll add, by the way, I'll make a promise to you. If you want my slides, I'll put them somewhere. I'll give them to somebody, and I'll finish translating them so you can have the references to these artists. Okay, I'm going to finish today because I am an artist. I do try sometimes to show at least one of my works. I've done many different kinds of artwork, many different technologies over my career, including, as Marcus mentioned, some activist things that I'm not talking about those things today. This is a piece that I did with my wife, my dear, significant, and better other, Paula Poole, called Silver Island Bunker Trail, that we did back in 2005. And what we did for this project was actually we used a kind of artificial intelligence, another flavor, if you will, of artificial intelligence called computer gaming AI, which is not AI. Most computer game AI is also not really AI. It's actually very simple algorithms that do things. But in specifically, and related into some work I did with a group called C5, I was interested in an algorithm called the A* algorithm. So I'll ask you a question. I'll give time for hands here. How many of you have ever been in a computer game and been chased by something? You hide behind the tree, it comes around the tree at you. You're way over here, but it knows where you are, and okay, that's the A* algorithm. It's a path-finding algorithm. And it's actually like ridiculously simple. It's actually just 2 stacks and some clever popping and pushing, but not to worry about that. I wondered, right, how because we walk very differently, as it turns out. We navigate very, very differently than the simple algorithm. So I wondered what the experience was like of a human to walk like this game algorithm. So we did this project where I wrote an algorithm that goes through landscape data, elevation data in the desert. And this is in the US state of Wendover, near Utah. And we created a hiking trail. So I wrote a kind of AI to discover hiking trails, like where to walk. Even though there's no trail there, you follow it with a GPS device like this, and you go this way, you go this way, you go this way. So that's the kind of things, that's kind of in my career, my kind of only engagement personally in projects with AI is AI generated hiking trails and going there to hike the trail in very, very remote desert landscapes, and building a tourist sign for the hiking trail that describes like where to go on the internet to get the GPS coordinates so you can follow the hiking trail. I don't think anybody ever walked it. I think we were the only ones. But people do read the sign at the Center for Land Use Interpretation in Wendover, Utah, where I'm sure it's becoming quite desiccated now. So, dear colleagues, thank you very much for, listening to my thoughts about AI and exploring these histories. I really look forward to putting these headphones on and receiving your questions and having a conversation. Thank you very much.
Pessoal, a gente vai abrir para perguntas, então, e vocês precisam perguntar no microfone para o tradutor traduzir, tá? Quem quiser também pode perguntar direto em inglês para ele. Quem for perguntar, levanta a mão, por favor, que eu passo o microfone.
Alô? You comment a lot about the AI hallucinations that tend to happen. And I'm very curious if it's something can be triggered purposely or it's something that just happens sometimes with the AI.
This is a major area. This is a major area of research right now because we don't know how they work, right? We don't know why they do what they do. So, and this kind of goes to the stochastic parrots essay, because one of the things that the group of scholars that are working in and around AI safety protocols are trying to do is they're trying to build guardrails, for example, to prevent chat. It's very important for Chat GPT not to be a shithook racist, right? It's very important. So they're trying to build the guardrails around this, but but we still don't know. You build guardrails, and there are people that like actively hack AIs to get them to do things to get around the guardrails. And this is very fascinating because any of us can do this. Like we can try with our intuition to trick the AI into saying something terrible or something stupid or something delightfully funny because it's so wrong, but it's also cute. We can try to get all of these results out of these things. And but the real focus has been to make them commercial products that don't offend everybody and that don't hate, because they're being fed with hate. Hate's going to come out of them at some point, right? But so this is your question goes to this whole area of research and how to do this. That's very hard, and that in which I'm not an expert. As an artist, the thing that I think is interesting is when they do hallucinate, like what can we do with the hallucinations? Because I think that says something about us too, because these things are kind of like us, and they are. They're a little bit like us. They're not us, but they behave a little bit like us. Like what, another of my colleagues, Benjamin Bratton, wrote a very interesting article that you can find in the New York Times about AI called Outing AI. And his take on AI is that rather than fear them, learn what we can learn about ourselves. So, I mean, I guess you could, around issues of racism and AI, you could make a case that what we're doing when we build these guardrails and make them not racist is that we're also erasing the terrible legacy of our own racism, which is what white people have been. It's kind of uncomfortable, especially in my country that, I won't speak for Brazil, but for the United States, it's kind of weird in my country that, and these companies are from my country, that the most racist people in the United States are the people who will insist that they're not racists, right? No, I'm not a racist, right? And here we have the model in big business of companies creating AIs that insist that they're not racist. What does that mean, right? That we're implementing what can be viewed as a kind of very, very racist attitude toward developing these systems. But anyway, I can't answer your question because I'm not a computer scientist, and I'm not a computer science scholar. I'm an artist who plays with, the discoveries of computer science and, takes pieces of them and uses them for my own weird projects. So I wish I could give you a better answer, but at least we were able to speculate on it a little bit.
Given on the idea of hallucination, do you know any article or research that talks about how the image development of AI, how they construct their image and develop something associated with the unconscious images of the human mind?
Yes, but I don't have exact references for you. Much of this research is going on at the University of California, Berkeley, that I'm aware of, and Stanford, and much of it's happening in medicine. So there are MRI techniques where they've been able to do MRI reading, apply artificial intelligence to MRIs, and actually extract images from people's brains. So like imagine a rabbit, think of a rabbit, and the MRI can see the rabbit appear in your brain and get the picture of it out of your brain, kind of, right? But there is, so, you know, the fields that have something to say about AI are, of course, like, you know, neuroscience. So neuroscience doctors, medical doctors are studying this in ways that are different from computer scientists, but overlapping, in ways that are different from cognitive scientists, but overlapping, in ways that are different from psychology, another field that has something to say about it, but overlapping, you know, separate also from philosophy has a lot to say about it too. So there is good conversation between these fields, but in terms of, I'm just aware of this particular research and I don't have a specific reference for you, but I've seen it. So I hope you'll find, if you look around, I think you'll find it. Yeah.
Do you have any suggestions for how to deal with AI anxiety in the creative industry?
Drugs.
Drugs.
No, I don't. Yeah, I have AI anxiety and other kinds of anxiety too. And
Did the drugs help
I am
with
not
that?
I am not a counselor or a psychologist. I don't know. I mean, you know, I do think something. I do have an activist kind of background, and I think following people like Timnit Gebru and becoming part of the conversation about AI safety and understanding what's going on with it is very important right now. And I think if you're part of the, even in little ways, part of the fight, that then and understand. I mean, I think there's a lot of comfort in these critiques of AI that can really help us understand the actual scenarios. And I like to think that like a, you know, a more toward rational understanding of what these technologies really are. What I describe in terms of art as medium specificity, like understanding what they do, how they do it, is very relieving because, in fact, you know, there was the famous letter that was signed by all of the major AI companies and Elon Musk and others that it was about a year and a half ago, I forget exactly, called for a suspension of all AI research, right? Because AI is very dangerous and it's going to destroy humankind. But the people writing the call for a delay or a pause in AI research are all the companies that are ahead and leading in AI research right now. So it was sort of what they were seeking really was kind of a regulatory capture of, you know, prevent competitors from researching AI while they continue, you know, dominating the markets. So I think as we understand how these systems really work, and I'm sorry to say it means learning some computer programming and experimenting with Python. By the way, also I have really good news about that though. If you want to do AI programming, it's easier than learning old style computer programming. It's actually easier. Using Python for AI, it's really much more about data competency than computer programming. I'll say that. The hard thing about learning computer programming is you're learning to decompose problems. The hardest thing about computer programming is understanding your problem, actually, and then decompose it into smaller parts and implement it in the language so the computer does what you say. But for AI, it's really more collect data, train a network. There's some design of the network, but you think about it, and then see then experiment with its outputs. So I think it's actually, in data science fields, it's much more accessible to start playing with artificial intelligence online, in things like Jupyter Notebook, Google Colab. These are places where you can actually take your own data that's your data, train an AI with it, and play with it. And it's really much more playful than it is the pain of like learning C++. So maybe that helps too, because the more we know how to, and I also say this to many students who ask about this, like, what about careers in AI? Thank you for not asking that question so far, but I'll answer it anyway. There's the human expertise in the field is important, but also being able to apply the data from that field to the artificial intelligence techniques is important now. So, I think in terms of how we might work with AI, these might be skills that we all learn, and they are not, there's some of the pain of traditional computer science learning, but it's different. I just want you to know that it's different, and it feels a little bit more fun to many of my students. Many of my students learn it before I teach it to them, which is how I know it's like more fun than what I teach. I hope that helps too. I think having an understanding of, really how the technology works allows you to, put it into the right perspective.
In this presentation, you did talk. Sorry. Testing.
I missed the question.
In this presentation, you talk a lot about stochastic methods and the importance of randomness in AI art research. A lot of older artists like Brian Eno, Yanis Xenakis use stochastic methods for producing art, and are taken as predecessors of an idea of self-producing art.
Yeah.
Could you say AI art could ever be self-producing?
Yeah. This is a very good question, and actually I don't know the answer to it, but I think it comes, sometimes good art comes, and maybe it's a little bit of the case that's apparent in my presentation, but good art comes out of a kind of co-evolution of the techniques and the artist. So it's like the artist, I'm more interested in the artist collaborating with the AI than I am assigning either one a primacy. I think it's the collaboration between the two. So, I would answer your question. I don't think so, but maybe. But if AIs become in other ways, if we get to the point really where we ascribe to artificial intelligence actual intentionality, right? Which I argue, I think it's pretty clear, doesn't happen yet. The kinds of AIs that we're using today don't have intentionality. That's my argument. So, they're not creative in the same way that people are. But people can be very creative with randomness. The artists you mentioned, they're fantastic, and they get criticized for the randomness, but no, it's like they can produce like really kind of like remarkable, famous work. So, but yeah, I think it's more, and I believe that they are interacting. I work with randomness too as a computer artist. Of course, I have. I believe they're interacting with the randomness in a way that contains the randomness with very good decisions. And that's a creative process. And I'm going to die on that hill.
Eu vou perguntar em português porque eu não consegui formular ainda a minha pergunta. Você comentou dos testes que são feitos de linguagem, onde você pega os tradutores, e vai passando uma frase por várias línguas. Eu queria saber se sempre parte do inglês, para chegar de novo no inglês, porque quando você falou sobre os language models e como se organiza essas espécies de redes neurais, eu fiquei pensando se talvez exista um centro, e esse centro seja o inglês, quando você faz esse exercício, assim, onde sempre a linguagem vai ter que passar. Ou se não precisa passar por isso, porque, sei lá, a gente estuda, sei lá, o Fanon, Francis Fanon fala muito sobre linguagem e a linguagem colonial e como ela se impõe. Então, eu queria saber se a gente pode pensar essas redes também de maneira mais vertical, e assim, como que a gente pode, sei lá, ligar esses pontos mais periféricos, assim, não tem tanta informação.
Yeah. It's purely an artifact of me being like a monolingual guy who has trouble learning other languages. So of course I start with English. And so I can't answer your question because I haven't done it the other way. But also, this is a really good idea for a project because I do want, my assumption, and I only assume this, is that like Google's pretty good starting from English and coming back to English. I don't know for other languages, and somebody should make this a research project. Maybe you should make this like a whole area of research because this would go actually very much toward also what the stochastic parrots argument is arguing about what these machines are, that the biases end up in the model because of how they're trained. Well, our models today for chatbots, not for translation, but there are different models. But our models for chatbots are mostly trained in English. They mostly know English. They don't perform right now. Things like ChatGPT don't perform well in all of the world's languages. They perform less well in languages not English. So you already have a case right there, right? Already for how chatbots aren't working. But when it goes to the specific thing of language translation models, I kind of assume that they work very well for China too. And that you would have but I have never done the experiment. And this is why we're here today. Thank you.
Thank you.
Oi, Brett. Obrigada pela sua presença aqui hoje. Eu vou perguntar em português.
Português.
Aqui, claro. E você, quando apresentou as categorias de alguns gêneros da arte e tecnologia, você algumas vezes disse assim, isto não é realmente inteligência artificial. A minha pergunta é, você considera a inteligência artificial algo que tem a ver com o algoritmo de uma forma ampla? Por isso você colocou aqueles exemplos dentro da categoria de inteligência artificial? Ou você, sei lá, ou você acha que a inteligência artificial já carrega em si a questão do algoritmo, por isso estava lá? Assim, você está considerando você mesmo ou você acredita que a inteligência artificial, per si, ela tem a ver com a questão do algoritmo?
Yeah, it's kind of it's a very good question, and it's kind of a semantic issue that's very contextual. So in my presentation, I presented what is and isn't artificial intelligence. The dividing line that I make is between classical computing problems that use the three control structures from computer science operating on data. So that's looping, exercising a sequence of commands, making a decision, true or false. If it's true, do this. If it's false, do that. That, for my talk, and maybe I should have built a legend for this. It's a very good point. But for me, the classical computer science techniques are not artificial intelligence, although they were called artificial intelligence many times. So for example, expert systems are one of the ones I think is not artificial intelligence. If you look at Harold Cohen's code, it's it's decision trees and loops and decisions. And if this, do this, measure the circle, compare it to this data. No, that's not according to my plan. Make that circle smaller. It's a whole sequence of steps and decisions and repeating those until it gets better and better that get used. So that's, in my talk today, that's the dividing line. But it's really important. Historically, like, you know, artificial intelligence was an if statement, right? If, you know, if the cookie is burned, throw it away. If the cookie is not burned, keep it. You know, put it in the box, right? That was called artificial intelligence. But what I prefer to call artificial intelligence are techniques that, you know, one of two things. One is to use, you know, randomness or the like population genetic algorithms, like the Darwinian model of, you know, you have a selection of solutions, you rate them by how close they are to the answer, then you learn from the remainders and make a new population and sort them again. Even though that's using classical computing techniques, it's producing functions that you didn't know existed. You're not a computer programmer writing the function, figuring out the right function. You're discovering a function. To me, that would be the just personally, that's sort of the threshold for what would be AI. But then of course, the neural network style programming. This is often this is really a true thing. People will call neural network programming neural network models, like large language models for language or generative adversarial models for pictures. We will call them, we'll term them as algorithms, that it's an algorithm doing that. No, it's not an algorithm. The neural network AIs have algorithms, they use algorithms, but they themselves are actually, for the computer scientists out there will understand this very well, they are data structures, right? We're asking questions of data structures. So, you know, again, representing the different weights of the different neurons in the artificial neural network. So they are not algorithms. So it becomes really clear then that when we get into really contemporary AI techniques, that it's something new. And I'll relate this to an answer to one of my previous questions that I answered, is that it actually kind of makes it a little more approachable for non-computer scientists. No, you still have to learn some classical computing. You still have, Python is the language to learn, you know, to begin to engage in, you know, any kind of artificial intelligence with any kind of neural network or language model, by the way, where you train your own model with your own data. You can get there, but, you know, it's not as hard, right? It's actually kind of good news about the most recent ones. If you're going to go write a genetic algorithm artificial intelligence, no, you want to be a really strong computer science and programmer for that. But then these are much more accessible to learn than they were before. So I definitely draw the line hard at, you know, neural networks, and I make my own kind of line for things like genetic algorithms. But if it's classical 3 control structures and data, no, that's to me not artificial intelligence, even though historically it was called that quite often.
Brett, eu queria te perguntar o seguinte, eu acho que uma parte importante da lógica de inteligência artificial é cálculo de médias. E isso significa excluir as exceções. Então, eu me pergunto se a sociedade baseada em inteligência artificial não leva ao risco da gente começar a excluir as exceções, né, e ficar só com as médias. E eu queria também te perguntar qual o papel dos artistas em garantirem que as exceções continuem existindo nesse ambiente da inteligência artificial. E se para isso é preciso programar ou se só ser um usuário rebelde já é suficiente.
Well, I think you both have to program and be rebel users, both and. But it's a very good question. And part of my response is that the large in large language models is collecting the exceptions, as long as the exceptions are in the data set, right? So if, you know, if we define like creatives, creative people, creative outcomes like genres as being exceptions, like the emerging, right? The new creative practices as they come about. If we, the question, the answer to your question is whether they get into the model, the training data or not. So that's a point. It's a very good point because it's a point of exclusion. What's not only, you know, some of the scholars that I talked about today, they're asking the question about the racism that is in the training data. But it's a very good question about what is not in the training data, right? So if it can't, for the AI companies that exist today, if it can't be images that they scraped from the internet, stole from all the artists to train their models against, if it's not the language of like Reddit is a big source of English language for training neural network models. Like the question is, well, who's not in Reddit, right? It becomes, so maybe there's an issue of representation, and this is the double-edged sword. Maybe there's an issue, a political issue of being represented in the data sets. But maybe there's also the political issue of, no, I don't want to be modeled by this technology and don't want to be part of it. But then the question of visibility of practices, right, is whether, like, do these become the new cultural norm for managing information? And do you want to be seen or not seen is a very, very important issue too. So I don't have like one answer to your question other than to lay out that kind of scenario of like representation in the training data. Is it a right to be represented correctly the way you wish to be represented in the training data? Is this a human right of some kind? Is it a right to, as they have in Europe, to be forgotten and to be excluded, removed from the internet so that you are forgotten? These are really hard questions. And I don't have all the answers to them other than to say, hey, typically I'm against, I'm opposed to like right to be forgotten, right? Generally politically, I'm opposed to it. But I could, with new large language models, I could start to question that because there are very definitely people that don't want to be seen. Hard problem. It's a very hard problem. Let's follow that up. I want to.
Thank you.
Yeah. Is there more to think of? I think there's a lot more to think about there. I want to talk. I want to speak about this.
I think so, yeah.
Let's beer and think about it. Yeah. Yeah.
Good idea. Tem mais perguntas, gente? Acho que tá bom para encerrar, né? Bom, pessoal, a gente vai encerrar. Eu queria agradecer o Brett, mas antes de encerrar, a professora Jane tem alguns agradecimentos a fazer aqui, né? Então, se você quiser...
Eu queria agradecer porque a presença do Brett aqui hoje é devido a uma colaboração que nós temos do nosso grupo de pesquisa de imagens científicas com a Unifesp e com a Unicamp. Então, nós obtivemos aí verba para trazer o professor Brett Stauban pela FAPESP por meio desse grupo de pesquisa. Então, temos de agradecer aos nossos colegas da Unifesp, o Cícero está aqui, agradecer o Alfredo, que não está aqui, mas que amanhã ele irá para a Unicamp, para poder também fazer uma palestra lá. E agradecer à PUC, principalmente ao professor Marcos Bastos, por toda essa organização, por estar aqui hoje conosco. Quero agradecer a presença de vocês, né? Acho que... e agradecer muitíssimo a presença do Brett, que veio depois de muitos anos, né, de Covid, etc., mais uma vez na PUC. Não é a primeira vez que ele vem aqui, e mais uma vez ele está aqui conosco, trazendo aí uma longa história com esse curso de Comunicação e Multimeios, de colaboração, de pesquisa. Né? Muitíssimo obrigado pela sua presença. Né?
Palmas para o Brett, gente.
Thank you.
Eu já tirei a foto de vocês, agora eu sei que todo mundo está presente, vou colocar na inteligência artificial, vai sair a presença e o certificado junto. Tá? É tudo resolvido, a partir de agora não precisamos nem mais fazer lista de presença. Mas, por favor, assinem, assim mesmo. Tá?
Thank you, Johnny. I have somebody's SD card. Or, I'm sorry. Yeah. Somebody's thumb drive.